In this problem, we're told a 3 kilogram block starts from rest at the top of a 30-degree incline and slides 2 meters down the incline in 1.5 seconds. Find A, the acceleration of the block, B, the coefficient of kinetic friction between the block and the incline, C, the frictional force acting on the block, and D, the speed of the block after it has slid 2 meters. Right, so this right here is our drawing, right? We have this incline, right? It's 30 degrees from the horizontal, and this block right here, which is mass 3 kilograms, is going to slide down the incline, right? 2 meters, and the time it's going to do it in, right? So the time it's going to take is 1.5 seconds. So just keep that in mind. And so that's basically what's going on. And so let's just go ahead and start solving the problem. So for A, what we're trying to find is the acceleration of the block, right? So for A, we're finding acceleration, right? And so keep in mind what we're given. We're given a distance, right? It's traveling. We're given how long it's going to take, and we're given its initial velocity, right? It starts from rest, meaning it's going to start from 0. So we know v sub 0 of the block is 0 meters per second because it's starting from rest. We know the distance it's going to travel, delta x, right? And we're also given the time it takes, right? 1.5 seconds. So if you notice, we're given a bunch of these kinematic variables, and then we're just going to solve it using kinematics, right? And so when you solve these problems, one thing to keep in mind is that you always count the direction it's sliding as the x-axis. So if you think about like a normal axis, this is the x-axis, right? But on this problem, you're going to think about this incline, everything along this line that I'm drawing is the x-axis, and everything along this line is the y-axis. So that's just how you think about problems with inclines like this. But now we've got all these variables, right? And so let's just go ahead and solve for A. So we're given v sub 0, we're given delta x, we're given t, and so if we want to solve for it, we know that delta x is equal to v sub 0 times t plus 1/2 at squared, right? We're trying to solve for A, so let's just go ahead and start plugging in variables. So delta x is 2 meters, right? Because it's changing 2 meters. V sub 0 is 0, and times t, which is 1.5, is still going to be 0, right? So we just have plus 1/2 times A, which is what we're solving for, times t squared, so 1.5 squared. We can get rid of the 1/2 by multiplying both sides by 2, so 2 times 2 is 4. So 4 equals A times 1.5 squared, divide by 1.5 squared. So the acceleration in this problem is just going to be 4, right? And then you're going to divide that by 1.5 squared. So plug this in your calculator, and when you do this, you're going to get A equals 1.777 and so on. I'm just going to round to right? So you can round how you want. I'm going to go ahead and round to, I'll just say 1.78. So 1.78 meters per second squared. But yeah, so 1.78 meters per second squared. You can round however you want, but that's going to be the acceleration. So now we've got acceleration. Let's do B now. So for B, we're trying to find the coefficient of kinetic friction between the block and the incline. So there's multiple ways you can do this, but let me show you the easiest way. So the way we're going to do it is by taking the sum of the forces in each direction. So the way this one, well, for this one, we're going to use the sum of the forces in the x direction, but for further on, we're going to do the other direction. So we're going to take the sum of the forces in the x direction, right? And so what are the sum of the forces in the x direction equal to? Well, keep in mind it's accelerating down, and we know the resultant force is equal to ma, right? So force equals ma, so this is just going to be equal to the mass times the acceleration, right? And so when you do these, when you take the sum of the forces and set it equal to ma, or 0 if it's not moving, but in this case it is, you set it equal to all the forces in the x direction. So the way we want to do this is by labeling the forces. So what forces do we have acting on our block here? So we have mg going straight down, right? Mg going straight down, right? We also have a normal force going up like this, right? I can't really draw it because I don't have a lot of room. And then we also have a frictional force, right, going this way that's slowing it down. So you could write F sub F, which is just the frictional force. And so we've got all these forces acting on it, right? So in the x direction, what are the forces we have, right? So the forces we have acting, right, is going to be, right, we have this frictional force, right? It's going backwards, right? It's going this way. So we label it, or you can label it negative, right? So I'm going to choose to label this negative. So this way is positive, this way is negative, down is negative, up is positive. So we're going to label this negative, right? So if it's negative, you just put it in here as negative. And then plus, right, what other forces do we have acting on the x? So we don't have a force directly acting in the x, but there's an x component of one of the forces, right? So notice F sub n doesn't have an x component because it's perpendicular, right? It's straight in the y, but this one right here is at an angle, meaning we have, if you draw it like this, you're going to have some force right here, right, which is the x component, and that's what you're going to be wanting to solve for. It's the x component of your force due to gravity. So we want to solve for that. So what you should know is this angle right here between perpendicular to the incline and where your gravity force is the same as your incline, meaning the incline angle, 30 degrees, is the same as this angle, okay? And so what we want to do is go ahead and solve for x, right? And so the way you do this is, or the way I think it's easier to see is if you draw a triangle. So imagine this triangle is the triangle that I created right here. So this is 30 degrees, right? We know this angle is 30 degrees. We know opposite to the angle is x, right? So you label this x. And then we also know mg is the hypotenuse, right? So this line is mg. So that means our hypotenuse of our triangle is mg. And what we want to do is solve for x. And the way we do that is with trig. So we know the sine of an angle, in this case 30 degrees, is what? Sine is opposite over hypotenuse. So the opposite is x, and then divided by the hypotenuse, which is mg. If you solve for x, multiplying both sides by mg, you'll get x, right, is mg times the sine of 30, which is what we wanted, right? So x right here, mg times the sine of 30, so just go ahead and plug that in, right? We're just laying out all the forces, and so those are the only forces acting in the x. We have the frictional force and the x component of gravity. And so what we're trying to do is solve for the frictional force. But keep in mind, we know all the other variables. We know we know the mass, and then we know all of this, right? So if we want to get it in terms of f sub f, right, I can add it to the other side and then minus, so the force of friction is equal to mg times the sine of 30, and then minus ma. All I did was add it and then minus ma. So if we want to solve, force of friction is m, which is the mass, which is 3 kilograms, times g, which is 9.8, times the sine of 30, right, minus the mass, which is 3 again, times the acceleration, 1.78. So go ahead and plug this in your calculator. 3 times 9.8 times the sine of 30, minus 3 times 1.78. And when you go ahead and do that, right, what you're going to get is this force, right? So 9.36, right? But keep in mind what we want to find. We're trying to find for B, right? For B, we're trying to find the coefficient of kinetic friction. So what we did in this problem, the way we solve it, is we actually found C first. So this actually is your answer to C, because this is the frictional force, right? This is what they want us to find in C. But we can solve for the frictional force, or we can solve for the coefficient of kinetic friction using the frictional force, okay? So keep in mind, this is really your answer to C, but I'm just going to keep this for B for now. But so we know the frictional force, right, which we just solved for, is equal to mu sub k, right, which is what we want, the coefficient of kinetic friction, times f sub n. So we want mu sub k. If we divide both sides by f sub n, right, we can solve. And so the force of friction, right, the force of kinetic friction, and if we divide by f sub n, it's going to give us what we want for B. So mu sub k, right, the force of friction is, if we just rewrite it, force of friction is 9.36, right? Divide this by f sub n. So what's f sub n going to be in this case? So the thing about f sub n is essentially, right, so if we take the sum of the forces in the y, right, it's going to be equal to 0. Why? Because our thing doesn't move in the y, velocity is 0, acceleration is 0. So 0 equals what forces do we have in the y? So remember how we had an x component for this one? Well, we actually have a y component of the gravity now that's in the y direction. Because remember how I said this is the y direction? So we have f sub n going up, and then we minus the y component, right? So I'll label this y. And so we want to solve for that. So if this is y on this triangle again, so we want to solve for y, which is going to be the y component of the gravity, you just take the cosine, right? So cosine of 30 is equal to what? Cosine is adjacent over hypotenuse, so cotilla. So the adjacent is y over the hypotenuse, which is mg. If you multiply both sides by mg, right, you get y. mg times the cosine of 30. And so, right, we just minus this force in the y, because we're just taking all the forces in the y. And so keep in mind, these are going to be the only forces in the y, right? Because frictional force is only in the x. And then mg, we got the y, and then f sub n. So if you add this to the other side, f sub n is just mg times the cosine of 30, right? And you can see that. So now we have f sub n, right? And we just take the force of friction divided by f sub n. So we're dividing by mg times the cosine of 30. So what's m? M is just 3, right? Times 9.8 multiplied by the cosine of 30, right? So you're going to want to go ahead and do this, right? So do 9.36 divided by 3 times 9.8 times the cosine of 30. And when you do this, you're going to get mu sub k, right? Which is 0.3676, and I'm going to round to 0.368. So you can round however you want. Generally, you just want to go 3 places though. So 0.368, and then keep in mind coefficient, right? Frictional force, or not force, the coefficient of friction, whether it's kinetic or static, is always no units, right? So 0.3678, that's going to go ahead and be your answer to B, right? So the coefficient of kinetic friction, right? This is your answer. So now we've gotten B, so this was B. Now let's go ahead and do C. So remember how I said earlier we did solve for C in it, like through the last problem. So we want to find the frictional force, right? Which is what we did right here. So remember what we did? We just took the sum of the forces in the x direction, and then that allowed us to solve for it, right? Because frictional force was the only one left, right? It was right here. So that's how we solve for it. So I'm not going to go through it again, but it's just 9.36, right? So 9.36 newtons, or about that, right? So 9.36 newtons. Yeah, that's going to go ahead and be your answer to C. Now let's do D. So for D, what we're trying to do is find the speed of the block after it slid 2 meters. So for this one, keep in mind for A, we used kinematic variables to solve for the we use kinematic variables to solve for the acceleration. And now what we can do is go ahead and solve for the velocity, right? We want to find the velocity at the end of the incline, right? So what are the variables we know? So we know how far it's traveling during this interval, right? 2 meters. We also know the time it's going to take, right? Which is 1.5 seconds. We also know the acceleration, and we know its initial velocity. So you can basically use any equation as long as it contains v, right? So you can choose which one you want. The one I think is easiest is we know v sub 0 is 0 meters per second. And then we're solving for v, right? Which we don't know. And then we also know a is 1.78 meters per second squared. So the one that stands out to me is v equals v sub 0 plus a times t, right? So we're just going to use that. So v equals 0 is just going to be, right, v sub 0 is 0, so we don't have to think about that. So it's just the acceleration multiplied by the time. So 1.78, right, multiplied by the time, 1.5. So go ahead and do this. 1.78, right? You can use the more rounded version or the less rounded version if you want, but it's just going to be 2.67. So v equals 2.67, and then it's going to be meters per second, right? These are the units we use. So 2.67 meters per second, that's going to be the speed of the block after it's traveled 2 meters, or essentially once it's reached the incline, right? Or it's actually not at the bottom of the incline, right? Because we just know it's traveling down the incline. We don't actually know the speed at the end. We don't know, because even though I drew it this way, really, we don't know if 2 meters is at the end, but just keep in mind, it's after it's slid 2 meters, right? This was the acceleration after, right? So the acceleration. And then, yeah, just keep that in mind. My drawing was a bit off. Well, it's not off, but it's really not at the end of the incline. But yeah, sorry about that. But this is, right, this is C, this is B, this is A, right? I didn't box it. This is A, and then this is D, right? So these are all your answers. And so, yeah, hopefully you found this useful.